Welcome to next session on Arduino based systems, and as discussed earlier in today's session, we shall try to finish as far as possible the architecture of the what we can say central part, heart of the Arduino board, that is the microcontroller. Once we fully know how that central part microcontroller functions at a block level, there is means we also need to define where to stop. If we go for very much details of the microcontroller architecture, then it's not that it's impossible for us to understand, but the time doesn't permit us. But we cannot even allow complete superficial level of knowledge just because that a high school guy can do. Understanding Arduino as regards to its utility is concerned is now quite simple. I would like to give an example which you can ask to your seniors or now to your even few parents who are aware of computer working with computer. When computers were there and many attachments were becoming popular, that time when USB was introduced in around 20 years back, or any kind of other, means that time something was to be connected to printer parallel port of CPU etc., of computer etc. So that time when new thing was added in the system, it needed many changes to be incorporated in the system, and that contained various drivers, and to make the computer ready with your new attachment was not also simple thing. It required some kind of skill set. That time computers were not connected to internet to this extent which are connected today. So with the help of a CD drive or even floppies, such drivers used to come, and it was a very tedious process. But what has happened today? Everything is plug and play. Just you bring it, you connect, and automatically it gets set up inside. Like that, the Arduino which comes with you, Arduino board comes with a USB interface, and everything is plug and play. You will be, I am sure that few of you must have gone through, or not few of you, I am sorry, all of you must have gone through the spoken tutorial videos, YouTube videos of programming with Arduino. So what I think is that is quite simple, and that is an obvious thing which student is able to do on his or her own, which doesn't require much kind of separate classroom teaching. So my focus is on our ability to understand the microcontroller, and especially for those who are somewhat interested, we will also have some kind of exercise of developing your own microcontroller at a thematic level. So as stated very clearly that how this entire microprocessor or microcontroller, the terms which I am using interchangeably, works is based on the fact that with the help of address lines, data lines and control lines, microprocessor is able to read the instruction, microprocessor is able to access the memory. Memory contains different locations, just like pages in a notebook. On each page something is written. So when I talk about the page now, I will make it more simple. What is a microprocessor? How it functions? To make you fully aware of functioning of microprocessor, I have told you in the last lecture that, or not for microprocessor, for anything for that matter, if we want to understand functioning of anything, that can be done when we assume ourselves to take up that role and how we would have behaved. And if I am able to chart out behavior of ourselves, if everybody is able to chart out the behavior of his or her oneself in order to perform the task which the device is performing, there is no impediment in understanding. मराठीत सांगतो म्हणजे एखादे मायक्रोप्रोसेसर असेल, ऑपरेशन ॲम्प्लिफायर असेल, डायोड असेल, ट्रान्झिस्टर असेल किंवा कुठलंही इतर डिव्हाइस असेल, इलेक्ट्रॉनिक्स मधलं असं नाही, कुठलंही डिव्हाइस असेल, ते कसं काम करतं हे कधी कळेल मला की त्या डिव्हाइसच्या ठिकाणी मी आहे असं गृहीत धरायचं आणि मी काय करणार, मी काय केलं असतं याचा एक मी सिक्वेन्स आखला आणि तो मी सिक्वेन्स नीट आखू शकलो आणि म्हणजे जर ते डिव्हाइस काय करतं ते त्याचप्रमाणे त्याची मी नक्कल स्वतः करू शकलो, इट मीन्स दॅट आय हॅव अंडरस्टूड दी वर्किंग ऑफ द डिव्हाइस and then I assume myself with some of my other person and then with a robo which is doing everything else. So by this process the understanding is complete. So see, remember one very important thing which I have told in the last lecture. Few of you might find that this is somewhat slow discussion, but I think that to understand the fundamentals we have to be slow, and latter parts which are just extensions can be at a rapid rate. If we give equal time to all contents in the syllabus, it will be a foolish approach. We should focus, we should dedicate more time in teaching to those things which are difficult, and for simple things we can rush through. Few simple things can be assigned as self-study with some difficulty solving interactive sessions. So externally speaking, the microprocessor contains, it is having 16 address lines, A15 to A0, 8 data lines, 2 control lines, D7 to D0, read bar and write bar. It is having obviously power supply lines plus 5 volt and it can also called as VCC. Now there can be somewhat lower voltage level operations also. New chips are there and it is having one clock and a reset. So once we reset it, and here the CPU starts functioning, clock is there from one falling edge of the clock to next falling edge of the clock is 1 clock cycle. In 3 clock cycles, one operation is completed by microprocessor, and that operation is either reading or writing. In the reading operation, it puts something on the address lines. It puts read bar low and text data. So now, what microprocessor can do? It is very limited. That is, what a microprocessor can do externally is very limited, either undergoing a read cycle or a write cycle. Either undergoing a read cycle or a write cycle. In read cycle, it can read one location. It has to specify the location which it wants to read. In a write cycle, it can write something into some location for which it has to specify address as well as data. Address as well as data. So, for me, if I assume myself to be microprocessor, I will specify 16 bit value, 16 address lines. I will specify read or write, and then if it is read, something will come. The memory is just like a notebook. In a notebook, on every page of, I am trying my level best to make it too simple. On every page of the data is how many bytes here, data, how many data lines are there? 8 data lines. So on every page of the notebook, so microprocessor is going to access this memory. It is 65,536 pages. It is having 65,536 pages. Each page contains one 8-bit number or 2 hex digit number. So on every page there is some number between 00 to FF, right? So 65,536 pages are there. I microprocessor, there is memory. What I do? I start. How I start, last time I discussed. At start, there is program counter in the microprocessor. It becomes 0. So in the first cycle, I say address 0. When address 0 is there, page number, so when I specify, page number 0 opens. Something is there on page number 0. Now when I say notebook, on the notebook, either it is like a pre-printed notebook or it can be a scratch pad. There are few locations on which I can write. There are few locations where I can't write. So I specify 0, read 0. So page number 0 opens, my eyes see that value. When my eyes see now I am emulating microprocessor. When my eyes see that value, what next is to be done? What next is to be done? Is there written, is there embedded inside me, and for what combination which I read, what I am supposed to do, that is designed by the designer of the microprocessor. Designer of the microprocessor are again you, because microprocessor itself is a structure which contains various gates. Even flip-flops are using gates only. Flip-flops are using gates only. So microprocessor itself is a structured digital hardware. That design, how actually it is done, is beyond the scope of our discussion. But how it works, that is the complete structural analysis of a microprocessor chip is beyond our scope. But it is designed to work in some fixed manner that we are discussing. So microprocessor can perform only 2 cycles. To see how simple it is. Just like a human being. I can talk, I can listen with another individual. So it specifies address 0 read, something comes. This thing is by default, it is hardwired inside the processor. So once it starts functioning, once it resets, power is there, reset is done, clock is active. So in the first cycle, it reads location 0, and then depending upon that is called as opcode. That opcode operation, op is operation, code is coding. So what kind of operations are further expected to be done by the microprocessor is coded there, and depending upon that I understand what to do. So 1 out of 256 combinations, 1 out of 256 combinations from 0 0 till FF. From 0 0 till FF, each combination tells me what to do. What I can do? I can, number 1, perform some computation inside, for which data is available inside. There are various registers, I had said. Register A, accumulator B, C, D, E, H, L. I can perform some computation. Or I can read some location externally again for some purpose. I can write something into some external location. I can change the flow of the program. Now I am going sequentially. No, program wants me to go somewhere else. That is called as subroutine, etc. So these are these things. Now, what is a microcontroller? That for that purpose we need to have some external ports. So some memory locations. So the memory contains 65,536 locations. For each location, for each address, a separate entity is referred, just like pages in a notebook with page numbers. For every page number, a new page is accessed. So for every address line combination, a new location is referred. Now that location, page in a notebook, as I had stated, either it is pre-printed or you can write. And next thing is, few of this is a memory chip. Memory chip contains exactly complementary lines to that of microprocessor. So 65,536 location memory contains one supply line, one ground, and these lines, address as input, data line as bidirectional, read bar and read input lines. So this is CPU and memory. So this is the So with this, any program can reside in CPU, in memory, and CPU will continue to execute that program. So continuously. Now suppose that you read something, and once your reading is over, examination is there. What you do? You go to the beginning to read. Similarly, the program can loop throughout. Once, just like there is no question of death in case of microprocessor. When we are living entities, with each breathing we do something. Continuously. Like that, microprocessor will also do something with each clock cycle. 3 clock cycles constitute a machine cycle, and in each machine cycle it will either read or write, and it will start from 0 and it will continue like this throughout. It will continue like this. Then there is, I will explain one interesting instruction, that is opcode 00 is for no operation, knob. In 8085, opcode 00 is for knob. I think there is no need to explain the meaning of knob, because which you normally all students do. Don't do anything, just kill time. So I read location 0. If in this memory at all locations 00 is stored, what will happen? I read location 0. I get the number at 00. So I don't do anything. I go for next instruction. So address will come 0001. Again 00 will come. Then 0002. Again 00 will come. So if 00 is stored at all memory locations here in that case the CPU will be just working as a 16-bit counter. After each clock cycle the address will become 0, first 0 0 0 0 0 0 0 1 0, then 0 0 0 2, 16-bit 0 0 0 3, so up to F F F F. What after that? After that there is auto rolling. F F F F is program counter, that will become 0 0 0 0. So it will simply a 16-bit counter. It will be simply a 16-bit counter. So if you don't connect anything and if you connect data lines to 0, in that case it will be a by default 16-bit counter. So do nothing. Now, so what CPU does is begin with reading the location 0 and then sequence your entire activities depending upon what is written at location 0, and for every byte written what is to be done is stored inside CPU in these 256 pages, which I have said that machine cycle encoder. Machine cycle encoder. What to do in case of which instruction? Like this. Then this CPU and memory is of no use to me unless I am having at least one output port, means the memory, CPU and memory, that discussion. Suppose if that then whether it's a discussion going on, yes, CPU is giving some address, memory is giving some data, CPU is giving some address, CPU is writing some data in the memory, everything is going on. Suppose that now there is one teacher, there is one student, and those are interacting on a, then is it seen for me? Yes, I can see this. The address lines, data lines, they change at a very rapid rate, but I can see that. So there is a television program on which a teacher is there. Suppose that now you are having some difficulties in examination is there and you have to prepare. Then there is a teacher and a student and a live show is there, and they discuss in a language of which you are not completely aware, you are not aware of totally. So is it of any use to you? No. Because what communication is there between teacher and student, which others are saying, that communication is complete, means it is a teacher, it is a student, say for example, some communication is there, but on address lines and control lines, but I can see that communication, but I don't access that, so it's of no use to me. So for this to be useful to me, memory must have some I/O locations. Actually memory and I/O there is huge discussion, but memory must have some I/O locations. So I say that let us for example, last 4 locations of memory, namely FFFC, FFFD, then FFFE and FFFF. So these are I/O locations, means the memory location when CPU performs. Suppose if I write the instruction, say LDA FFFF, means what will happen? Whatever LDA FFFF means what? Microprocessor will generate the address FFFF, will generate read bar, and whatever is stored there inside this memory will appear on data lines. When address is FFFF, So except these 4 locations, all locations are inside. The lines are not coming out. So what is an I/O port? This is a definition which I am giving for simpler understanding and not a classical definition. What is an I/O port? Let it not be jumbled with your either previous knowledge in 12th vocational or with some other reason by knowing or by trying to verify it with other experts. I am giving this definition only for simpler understanding. This is not a classical definition. So what is an I/O port? I/O port is nothing but a memory location. Only thing is that the lines are separately accessible to the user. So this is a 64K memory which contains 4 memory locations which are I/O ports. 64 means the memory which is having a capacity of 2 raised to 16 contains 65,536 locations. Of this 65,536 locations, 65,532 locations are 65,532 locations are not accessible to the user and 4 locations are accessible to the user. So the 64K memory contains 4 I/O ports. So that memory location which is accessible to the user as I/O pins is called as I/O port. And once this is there, once the instruction set of for a given, so in all, what is CPU? It contains some internal storage locations called as registers, and it can perform some arithmetic logic operations inside. It can perform a read, it can perform a write, and there is a definite manner in which how the things are to be done. That is, the instruction set is appropriately designed with appropriate opcodes. So CPU can read the program which is there inside. So when you get a printed book, on every page something is printed. Do you worry who has printed? No. So your role is that yes, pre-printed book is possible, you are supposed to read. Like that, this memory contains few locations which are permanent, few locations which you can change, few locations which get evaporated if power supply goes, few locations which continue to have the data even if power supply goes and come back. So temporary storage, permanent storage, then writable area, non-writable area, and I/O area. So memory contains read-only, read-write, temporary, permanent, and I/O locations. So each I/O locations are nothing but pins. So suppose if I want to perform now with these pins, what happens now is that this now is not required for me. The entire thing, this memory is also part of CPU. This memory means in earlier versions, when VLSI was not so much advanced, CPU used to be a separate chip, memory used to be a separate chip. Now this memory can be part of CPU. Memory can be part of CPU. So it will be a chip which is having 32 pins. So what we can have is, we can have a microcontroller, very crude definition I am giving. We can have a microcontroller which contains CPU and memory, and with memory with few, let us say 4 I/O locations, can be I/O port also, means these can be bi-directional, you can set that, but right now it is not important. We will discuss it in actual programming. So in general, we can imagine of a 32 I/O pin device. So we can think of a CPU and memory combination which can obviously plus 5 volt and ground, reset, and this clock is to be given externally, let us say for the time being, and so this is port 0 output, port 1 output, port 2 input, port 3 input. So these are 4 memory. Now CPU is inside, memory is inside, and only last 4 locations of memory which are accessible to the user have come out. So 32, 33, 34, 35, 36. So this would be a microcontroller chip. This will be a microcontroller chip which will contain 4 I/O lines, 2 input ports, 2 output ports. So 32 I/O lines and 65,532 other locations, that is inside. Now the problem would be the memory is there inside, so how to write that? Then few years back there were chips called as ROM, factory manufactured read-only memory. So I have to supply what program should be there to the factory and the manufacturer will give that. But after that, then the advanced technique came that I can program it. So now what we are discussing, we are now aware that there can be CPU, there can be program, and CPU can execute any program in the memory, and the program is such that it will refer these locations also. So once I am able, now we are talking of CPU in actual industrial automation for some kind of performing some kind of actual operations for the user. So in that scenario, so what CPU can do, as I had already stated, as regards to external things, CPU can read a location, CPU can write into a location. That's all. Now if the location which CPU can read is that location which I can change using switches, in that case, whatever I set on these pins, CPU will read that. And what CPU I will write in the program, if one particular pin is 0, what should be done? If one particular pin is 1, what should be done? And CPU will do that, and it will output the things on few other lines on which there can be LED, I can see that, or that can control something like a relay. Suppose if I want to have a motor, start a motor, so that pin will be becoming 1. Once that pin will become 1, the motor will start. So multiple switches are there. Based on multiple switches, based on their appropriate combination, the things will begin. So as regards to microcontroller, what is there is depending upon, so now there I have got 2 ports, which input ports. I have got 2 input ports and I have got 2 output ports. Then what can be done is, depending upon the combination of input ports, means I can go for any kind of programmable hardware arrangement using CPU. So suppose if that when this concept of CPU was not there and some kind of digital things were there, then that time a combinational circuit was there. What is the simple most thing? 2 input pins, 1 output pin. Y. So you had OR gate, A, B and Y. So we write Y equal to A plus B. That is in A0, B0, Y0. A, B and Y. A0, B0, Y1. A0, B0, A0, B1, Y1. A1, B0, Y1. A1, 1, 1. So actual gate was there. Suppose if when you want to change this gate with AND gate, you have to change the actual chip. Then you can have multiple cascading, so that a combinational circuit consists of, for this combination of input pins, and there can be one output, then there can be other combination for same inputs. Means what we simply can have is just like same inputs A and B, there can be other element, so the same inputs will be there. This is, I can say Y1, I can say Y2. So what is Y1? Y1 is A plus B. What is Y2? Y2 is A dot B. So in general, a combinational circuit consists of few input lines, few output lines, and there is an equation for I/O. For each output line, there is a specific equation. So multiple input, multiple outputs. Then there can be feedback, as we discussed in the sequential circuit. So in general, this circuit requires a dedicated hardware. And once you want to have some change, you have to change the hardware. Now what you can do? Now all these things you can do with computer based system, microcontroller. So microcontroller provides you a configurable hardware. For the same pins, if you want to change with new equation, don't make any changes in the actual hardware. Just change the program. And now, how to have this program, how to put something in this memory. So for that purpose, there is serial input pin. This discussion we can't have in detail. Serial input pin. Now everything is USB, that is a different issue. So using that serial input pin, the programmer, means a separate hardware, that is EEPROM programmer was there. A separate hardware can put program inside the memory of the CPU, inside the microcontroller. Just like when we use the notebook, what you do, you have some sincere student in your class. That sincere student writes it and you use that. So somehow there must be some technique with which whatever things are to be stored here must be put inside. So that is done by programming. So what we do is we configure the things in such a manner that a program resides. Listen very carefully. We have to end somewhere. We can't have this endless discussion. A program resides in the microcontroller which will read the input port pins, and depending upon what is there, it will activate output port pins of the microcontroller. Means what a microcontroller is, or if it is microprocessor thing, CPU is different, memory is different. Then you can have things put in the memory separately and put that chip, but those days are gone. That chip has come inside that memory chip, and CPU have, means that von Neumann architecture has come as a package inside the chip. So CPU and memory both reside in a single chip. And the physical pins are accessible for me. So a microcontroller chip comes with 32, just as an example I am telling, 32 port lines which are accessible to the user, and the program which will refer these pins and do something based on the status of the different input pins, and activate different output pins in a structured manner. That program resides. That program you can change the way you like. So initially I had said what CPU can do. Now what I would like to further tell, what is microcontroller. So listen very carefully. Microcontroller is an arrangement in which microcontroller is listen very carefully, we are coming forcibly to an end because of the time constraint. Listen very carefully. Microcontroller contains a microprocessor chip, a memory. Out of this memory, some part is pre-programmed somehow, some part is available for internal calculations, and 4 locations are available for user interface. The single chip contains microprocessor completely, memory completely, and 4 locations of memory have come out as 2 input ports and 2 output ports. That's all. Then now the microprocessor itself can be designed by an individual. Few decades back, the given microprocessor, say 4004 or 8008, then 885 or Motorola 6800, these different microprocessor chip names and their assembly language programming was considered to be a highly specialized skill set, but nowadays those days have gone. In general, you can design a microprocessor. What microprocessor does? Microprocessor reads the memory and sequences its actions depending upon what it reads. What it can do, it can perform some computation. So now CPU is a different chip. It contains some internal memory location called as registers. The memory is another chip which contains huge number of locations, but those two separate chips have been now put in a single chip. That is microcontroller. So microcontroller is CPU plus memory which which has got 2 output ports and 2 input ports, and this serial input to program memory is separate. Right now we don't discuss. So what we can do is, what comes with us is this arrangement, and this arrangement is with so what we want, now listen very carefully, things have completely changed. So the system comes with CPU and this memory. Of this, these are port lines. So for me only 32 lines are available, and this one, so I write this clock and reset here. The reset, it's a chip, it's a pin of the microcontroller. Clock is also pin of the microcontroller, and a bidirectional serial interface. And this serial interface is with CPU. And this you connect with computer. This is USB, and obviously ground is common. So now the program is there inside the chip. You want to develop some program. What program you want to develop, that program will then now do you need to know all assembly language programming? Not necessarily. You simply specify what you want to, what actual actions you want to take. That program, now listen very carefully. You should always ask a question, how things start after reset. You bring the system, you start it. Then you start executing from zero. Means there will be some permanent part inside. When you bring it new, that part will establish a separate communication. This, in fact, this is a serial interface pin of microcontroller. Means that discussion means CPU also has got one serial input output port. With this, it will communicate with computer. So there is a program inside. Using that program, this computer, using this program, this microcontroller it is now not exactly, but a small step in adapting towards, not exactly AI, but just I am showing the way. Just like how you learn. So this microcontroller contains a program. This program is such that with the help of this program, microcontroller establishes a communication with computer program. When you connect CPU and microcontroller to each, your computer and microcontroller to each other, the communication starts, and by using advanced user-friendly interface on your terminal, you are able to write that program which you want this microcontroller to do, and then you can start. So that it is possible to pre-program the microcontroller board. So this is now Arduino. So this is Arduino. So Arduino is microcontroller, computer interface and user interface. So this is microcontroller, this is computer, that is U, this is user interface. So what you can do, the program, when the system starts, it is possible that a brand new Arduino board you bring, So when you bring a brand new Arduino board, it does not contain user program, it contains some system program. With the help of this system program, the user can write here the program which he desires that microcontroller should execute, and once that is done, this interface can be disconnected, and in that case that Arduino board will be able to perform its operations independently. Arduino board will be able to perform its operations independently. So Arduino board requires computer interface to begin. Then using computer you can program Arduino, and then you can disconnect, and that Arduino board can work separately at the desired location. So, but I think in our discussion we will be working it with interface on only. Then what is Arduino? You have CPU, now you are learning computer programming. You are learning computer programming in which everything you are say some kind of C programming you are learning. So some calculations you do. But what is the thing? That you do something using keyboard and you see everything on screen. So input output in computer programming, or you use computer not only for computer programming but for all other kinds of applications. But everywhere your input is with the keyboard or mouse and output is the screen. That's all. When I say Arduino board I am interfacing, is what does it mean? Is that I am connecting a USB attachment. I am connecting a USB attachment to which I am having Arduino board, and I have these 32 pins. I have got 32 separate input output pins. To input pin I can connect a switch. To output pin I can connect a LED. To output pin I can connect a relay. Then the difference in everything